You may have heard this statement before that accidents don't just happen, they are caused. Yeah, that's very correct. Accidents don't just happen, there are always causes to any accident that occurs. And in fact, if you recall, one of the 8 principles that we discussed in HSE Level 1 is that all accidents are preventable. And the reason why that principle is there is because we know that accidents are caused, and if they are caused, then they can be prevented. And that's why that principle says you must understand that all accidents are preventable. Accidents are rarely simple in terms of the causation, what causes them. It's never really only one thing, okay? They never result from a single cause, like I've said, and they usually would involve multiple interrelated causal factors. That is the nature of accidents, and this is important because it helps you, if you understand the accident causation model or how accidents are caused, then it will help you to know how to properly plan for them and prevent accidents. When we talk about the causes of accidents, we have 3 types of causes: the root cause, the direct cause, and the contributing cause. Let's start with the direct cause. The direct cause of an accident is comprised of the immediate events or conditions that resulted in the accident. You may say the accident or incident itself. The direct cause usually will be stated, for example, as the accident was caused by contact between the screwdriver the victim was holding and the 480-volt energized electrical conductor in a circuit breaker. Now, that is the direct cause of electrocution for that particular personnel. That is an example of direct cause. Identifying the direct cause of an accident is usually simple and straightforward, but the direct cause is often not the most important factor in determining what actions may prevent future or similar accidents. Therefore, we need to consider the contributing causes as well as the root cause. Contributing causes are events or conditions that collectively with other causes increase the likelihood of an accident, but they did not individually cause the accident. Contributing causes may be long-standing conditions or a series of prior events that alone were not sufficient to cause the accident, but were necessary for the accident to occur. They can be said to be the conditions that set the stage for the accident, and if allowed to persist or reoccur, increase the probability of future accidents. For example, inadequate lighting in the work area created visibility problems that contributed to the contact between the screwdriver the victim was holding and the 480-volt energized electrical conductor in the circuit breaker box, as earlier mentioned. And now to root causes. Root causes are the causal factors that, if corrected, would prevent recurrence of the same or similar accidents. Root causes may be derived from or encompass several contributing causes. They are higher order fundamental causal factors that often address classes of deficiencies rather than single problems or faults. Correcting root causes would not only prevent the same accident from recurring, but would also solve deficiencies that could cause or contribute to other accidents. They are identified using root cause analysis. Of course, based on this description, it's obvious that root causes are the primary cause or causes of the accident, and if or when they are dealt with, then it will not be possible for those accidents or the accident to reoccur because the root cause has been removed. And this is why it is important that accident investigation understands the accident causation model and attack not just the direct or immediate cause or contributing causes, but essentially uncover the root cause and address the root cause. You then discover that in many cases, root causes are failures to properly implement safety procedures. Root causes, for instance, can include failures in management system to define clear roles and responsibilities for safety, ensure the staff are competent to perform their responsibilities. That means a lack of training. Ensure that proper resources are available. Failure to ensure that hazard controls are in place and adhered to, as well as failure to ensure that work is properly reviewed and authorized. You'd find that a lot of times root causes of accidents in the workplace are as a result of failure of management or of the management system. As earlier mentioned, accidents are caused, and often they are caused by more than one cause. And that's why we talked about root cause, we talked about contributing causes, and we talked about the direct cause. Accident causation models are useful in analyzing accident investigation findings. And we're going to look at a number of accident causation models. The following is a brief outline of some of the accident causation models that can be applied when investigating accidents in order to get to the root cause and uncover the causes of the accident with a view to remedying these causes to prevent recurrence of accidents in the future. We're going to be looking at the domino theory, the refined domino theory, as well as the tree diagram. According to the domino theory, the events leading up to an accident are like a row of dominoes as shown in the diagram from domino 1 to 5. Once one domino has been knocked over, the next event quickly follows. Notice that the accident and the injury have been separated in this diagram. This is because although the accident often occurs at the same time as the injury, losing the top of a finger in a circular saw, for example, this is not necessarily always the case. In some instances, there are long latency periods that can occur between the accident and the injury. For example, between the accident of being exposed to a harmful chemical and the ill health, which may result between 10 to 20 years from the time of exposure. Based on this, you find that accident causation models typically would distinguish between the causes of the accident and the resulting injury. The simple explanation of this domino theory essentially, in the way that it aids in investigating accidents, is to look at the number one domino, which is ancestry and social upbringing, saying the main or the fundamental or the root cause is the ancestry and social upbringing of the person. And of course, because the focus is on the person, then it suggests that there is someone that is at fault for an accident. The person goes ahead, and because the person has certain ancestry and social upbringing, would typically take part in unsafe act or unsafe behavior, and then the accident would occur, which will lead to an injury. Now, this domino model is of very little value in accident prevention terms, as it always focuses on the fault of the person. A person may be at fault though, but usually there are other causes involved as well, hence the need for the refined domino theory. The refined domino theory is also based on the same concept as the domino theory, that is, looking at the dominoes 1 to 5, starting from 1. Once 1 happens, then it goes on to 2 and 3 and 4 and 5. However, in this model, that is the refined domino theory, the model does not place the blame of the accident on the person. If you recall, in the domino theory, it was ancestral and social upbringing, and then the fault of the person, and then unsafe acts and unsafe conditions, then accident and injury. But in this case, the emphasis is on the management system. So the number one thing which is at the root cause, which I had mentioned earlier on, is the lack of management control, then unsafe underlying causes, which brings about unsafe acts and unsafe conditions, and then accident and injury. Unlike the domino theory, where the issues with that theory had to do with focus on one cause, focus and blaming of the individual, in the refined theory we see that there is more emphasis on management failure, which HSE claim accounts for at least 75% of accidents. There's little emphasis here on individual failure, even though it still has a single causation approach. So let's look at the tree diagram, which is another accident causation model. And this is considered a more useful technique in analyzing the causes of accidents, because this helps us to look beyond just one causal factor. It helps us to consider the direct causes, underlying causes or root causes, and multi-causal analysis. And this essentially is what we refer to as the tree diagram, because it looks at multi-causal analysis of the accident. Careful use of this technique can lead to identification of direct causes, indirect causes, and underlying factors which contribute to the accident. A good approach to identifying these underlying factors is to use the technique known as MIP. This involves identifying underlying factors relating to the materials involved, the equipment being used, the environment being worked in, and the people involved. Now, in the tree diagram, the underlying factors are stated when you look at it from this multiple approach of materials, equipment, environment, and people, then lead to underlying causes and sub-causes of unsafe acts and unsafe conditions, which then lead to the unsafe act or the unsafe condition or both, and then to the accident and then the injury. So this represents the basic tree diagram used in multi-causal analysis. You would have noticed that in all of the models, the domino theory, the refined domino theory, and the tree diagram, unsafe acts and unsafe conditions ultimately lead to the accident and then the injury. A large number of accidents, of course, are caused by unsafe acts or unsafe conditions, or by a combination of both. Unsafe acts often relate to human factors such as competence, motivation, attitude, and perception. They need to be addressed by controls such as culture, training, awareness raising, involvement, empowerment, and ownership of safety problems. Unsafe conditions, on the other hand, often relate to physical problems such as lack of machine guarding or high level of airborne contamination, and these need to be addressed through engineering and physical controls. Again, we'll talk about controls a bit more later on in this course. Only when a safe person works in safe conditions will the potential for accidents be greatly reduced. Therefore, accident investigation needs to concentrate on both unsafe acts as well as unsafe conditions. Another concept that helps with accident investigation and understanding accident causation is the accident triangle. Studies by various experts, as revealed in these three triangles, reveal that without proper control, near miss and incidents will eventually result into fatal accidents. For instance, when we consider the Enrich 1950 accident triangle, Enrich says that 300 no-injury accidents, if nothing is done about them, will lead to 29 minor injuries and then lead to one major lost time injury. This underscores the importance of investigating all accidents. So as seen from the findings of Enrich, Bird, as well as Ty and Pearson, Although we see that the figures below vary, or the figures for each of these accident triangles vary from study to study, the basic principles remain the same. The no injury incidents or near misses in each case have the potential to become events with more serious consequences. However, not all near misses involve risks which might have caused fatal or serious injury. What all the events do indicate is the failure of control. That is, if the near misses at the base of the triangle are not prevented or they are not controlled, then they will lead to more serious injuries and eventually to fatalities. Therefore, the near misses at the base of the triangle provide for us opportunity to prevent accidents from occurring. So if action can be taken at this level, then the chances of more serious injuries occurring will be greatly reduced.